Happy Wednesday, everyone. Today we are going to learn about more operations with rationals. We're going to focus in on adding and subtracting rational expressions. When we add and subtract rationals, let's look back at our pre-knowledge packet. When we add and subtract rationals, we have to have common denominators. So for example C, when we added 2/3 plus 1/6, they don't have a common denominator, so I multiplied 2/3 by 2 in the numerator and the denominator to keep the fraction equivalent and to make the denominator 6. So I have 4/6, which is equivalent to 2/3. It just has the same denominator as the other rational that I'm adding it to. And then 4/6 plus 1/6. Once you have common denominators, you can just add the numerators straight across. 4 plus 1 is 5, and keep the denominator the same, 6. So you're adding 4/6, and 1 more 6 makes 5/6. Same is true when you subtract fractions or subtract rational expressions. You need common denominators. So our first example is simplify 3x over x squared plus x over x squared plus x. Now in this example, the denominators are the same already. Yay, less algebra. So all I need to do is add the numerators. 3x plus x is 4x. Keep the denominator the common, x squared plus x. And then just like in the multiplying and dividing, we need to simplify this expression if we can. And in this case we can because the denominator can be factored. So 4x cannot be factored, but the denominator I can factor out an x. I'm left with x plus 1. X over x simplifies to 1, so my final answer is 4 over x plus 1. Example 2. What if we don't have common denominators when we're adding rationals? So 7 over 9x plus 3x plus 3 over 9x squared plus 9x. We do not have common denominators, so we have to figure out what do I need to multiply one of my denominators by, multiply, so that I do have common denominators. And in order to do that, it helps to see your expressions factored. So the first expression cannot be factored, I'll leave it alone. But the second expression, I can factor out a 3 in the numerator. And I can factor out 9x in the denominator. Now I can see 9x is common already, so in order to make the denominators equivalent, I need to multiply the first rational expression by x plus 1, and whatever I multiply the denominator by, in order to keep my expression equivalent, I have to multiply the numerator by it as well. So I have 7 times x plus 1 over 9x times x plus 1 plus 3 times x plus 1 over 9x times x plus 1. Now I have common denominators, so I can add straight across. So I have 7x plus 7 plus 3x plus 3 over the common denominator. And I can simplify 7x plus 3x. Combine like terms, I get 10x. 7 plus 3 is 10 over my common denominator. Factor to simplify further. If we can, and in this case we can, the numerator I can factor out of 10. Leave the denominator. X plus 1 divided by x plus 1 is 1. And my final answer is 10 over 9x. So when I add these two rational expressions, I get 10 over 9x fully simplified. Done. Last example for adding. Example 3. 2x over x plus 1 plus 2 over x minus 1. There is nothing to factor, and my denominators are not the same. I have two separate factors. So when this happens, there is not something that I can multiply one denominator by in order to get it equivalent to the other. So I need to multiply each denominator by the other. Meaning, multiply this denominator by x plus 1. Whatever I multiply the denominator by, multiply the numerator by the same thing to keep the rational expression equivalent. And this I need to multiply by x minus 1 in the top and the bottom, numerator and denominator, to keep the expression equivalent. So I have 2x times x minus 1 over x minus 1 times x plus 1 plus 2 times x plus 1 over x minus 1 times x plus 1. Now I have common denominators, so I can add straight across. I have 2x squared minus 2x plus 2x plus 2 all over my common denominator. Simplify by combining like terms. Negative 2x plus 2x is 0, so my numerator becomes 2x squared plus 2 over x minus 1 times x plus 1. And then factor. The numerator can factor out a 2 first. The denominator is already factored. And then I cannot factor this any further. So that rational expression is my final answer. If you have questions on adding rationals, ask your classmates, find a video on YouTube, or send me a remind.